All right, welcome everyone to our last SAT math review. So if you have any questions, please feel free to pop them in our Vimeo chat or ask it on our Fiverr website, and we will get back to you as soon as we can. And if you have any questions for me, you can ask them in Vimeo. I'll be kind of hopping back and forth to make sure that you don't have any questions or that I answer your questions when we're going through some of our practice problems today. But welcome again to our last SAT math practice, and we'll get started right now. Again, just make sure that you're following us on Twitter, Instagram, that you're subscribed to us on YouTube, and that you have joined our community Discord server. All right, so here's a quick little icebreaker before we jump into our pretty big practice deck today. So which of these puppies' facial expressions best represents how you're feeling right now on a scale of 1 to 9? Okay, seeing a 3. Someone else said 8. 7, 2. It's a pretty good mix. Yeah, seeing a lot of 7s or 2 7s. That's a good one. Haven't seen any 1s yet. Okay, an 8. Yep, now a couple 8s. This is pretty spread out. I'll give you a couple more seconds to type your expression into the chat. Yep, 3 is the cutest. I do agree with that. All right, so you can still pop some answers in the chat. We'll move on just for the time being. Again, this is a reminder of some information you've all seen before, the 2021 to 2022 SAT admin dates. We'd just like to remind you all of the test dates so that if you know you need to take the SAT soon, you know when the dates are, so you know when you need to register. All right, so today we're going to be covering a pretty in-depth review of quadratics in the advanced math section on the SAT. Again, this is all stuff you've seen before. Make sure that you bring your face covering, your admissions ticket. It's going to be emailed to you after you register, photo ID. There are a bunch of acceptable calculators they have. It's on the College Board's website, so you can check that out there too. Again, these are 3 of the more commonly used calculators. I would say the one on the right, or the smaller one, the smaller calculator, is not as frequently used as the 2 to the left. So again, those are just some acceptable calculators you can use, and we'll be covering some calculator questions today. So if you want to take this second now to go grab your calculator, you're more than welcome to do that. But our calculator section will be after our non-calculator section, so you don't have to get it right now. Again, this is another reminder, the non-calculator section is 25 minutes, about 20 questions roughly, and the calculator allowed section is longer, it's 55 minutes, and you have about 38 questions. Okay, so the calculators that are allowed for the SAT, again, approved by the College Board, some general tips and tricks. Don't bring a calculator that you have never used before to the SAT. Again, try out a few practice tests with your calculator of choice. Make sure it's approved, and if it's not approved, again, we haven't really seen this before. When I've taken the SAT, I've never really seen anyone bring in a calculator that isn't approved. There are some calculators that are maybe within $5 to $10. You can pick them up at Walmart, or you can order them off of Amazon, so I'm pretty sure everyone should be set. And again, this is stuff you've seen before, our major content areas. So we've already covered the heart of algebra, and we've already covered problem solving and data analysis. And today we're going to be covering the passport into advanced math, as well as some additional topics in math and quadratics. So quadratics and advanced math, it falls under the passport to advanced math, which is one of the sections that we saw on the slide before. So quadratic expressions and equations fall under quadratics and advanced math. You also have function interpretation, graph interpretation, polynomial manipulation. So do you know how to add, subtract, multiply, and divide polynomials, as well as some radical, rational, and absolute value equations with function notation, which function notation is seen pretty much throughout all your quadratics, so it's a fundamental skill. So some of the key concepts and skills that you should have mastered going into this section are being able to use a quadratic formula. There's always at least 1 to 2 questions on this minimum on the SAT math section for using the quadratic formula, so make sure you know how to use it. They might provide that to you on your formula sheet, I believe, but if they don't, make sure you just know it. Operations with polynomials, like we mentioned earlier, adding, subtracting, dividing, multiplying, those things would be great to remember. Interpreting graphs, critical thinking and reasoning, and also analyzing different expressions to deduce what they mean. So being able to convert an equation into what it's actually trying to represent, like miles per hour or feet per second or something like that. And just keep in mind that these advanced topics and quadratics cover about 30% of the total questions on the math SAT, so it's a pretty big section. All right, so if you want to grab a pencil and some paper, or if you want to grab something to write on, we're going to start with our first set of non-calculator practice problems. You can type your answer in the chat either on Vimeo or on our 5able.me website, and make sure you post any questions there so I can see them and respond to them hopefully when we're going through our problem sets here, or another TA will be able to help you out. But without further ado, let's get started. Okay, so our first question is, which of the following is equivalent to 16s to the 4th power minus 4t squared? I'll give you about 45 seconds to respond to this question, type your answers in the chat, have some time to work it out, because that's approximately the amount of time you'll have per question on the actual SAT, and then we'll go over it. So you can take your 45 seconds now. All right, so let's jump into the solution. And again, if you're still working through it, no worries. You can keep working through it while we're talking about some advice and some tips that we have. So if you said C, your answer is correct, and I see a lot of C's in the chat, so good job, everyone. Let's kind of go through some advice that we have for this question. So again, it's all about recognizing patterns. A lot of SAT questions draw from patterns, and they draw from past questions as well. So if you recognize something familiar about this problem, that's because it's a difference of squares. So a difference of squares is essentially where you see x squared minus y squared, which can be factored into x minus y and x plus y multiplied together. Of course, your x and y terms can change. So if you have a squared minus b squared, then that can be factored into a plus b times a minus b. Again, recognizing these patterns can really help you answer your questions quickly and set a faster pace, which again gives you more time to check things over and ensures that you might have a greater accuracy. So does anyone know how this equation demonstrates an understanding of the difference of squares? You can type it in the chat or just think about it in your head. Okay, we'll just move on, and don't worry. If you don't ever know a question or you don't feel comfortable typing it in the chat, we'll just wait about 10 seconds and then we'll move on. All right, so let's break down the solution. So we're given 16s to the 4th power minus 4t squared. So let's break that down further. We can break down 16s to the 4th power into 4s squared squared minus 2t squared. And if you, again, want to check your answer as you're going through, if you expand 4s squared squared minus 2t squared, you should get yourself back to 16s to the 4th power minus 4t squared. Again, this gives us now a difference of perfect squares. So then we'll break this down further into 4s squared minus 2t times 4s squared plus 2t. Again, if you substitute in the 4s squared for x and the 2t for y, this is the same principle as x squared minus y squared, factoring into x minus y times s plus y. Then you can factor out a 2, multiply your factors of 2 to give you 4, and that would lead us to option C. All right, so this next question is a grid-in. So this next one's asking us what the sum of the solutions would be for 2x minus 1 squared equals x plus 2 squared. Again, I'll give you all about 45 seconds. You can type your answers in the chat, and then we'll go through some solutions and advice. And again, because this question is a grid-in, it's not multiple choice or multi-select, which is not offered on the SAT. So for this question, you'd be gridding in a number or a value. There are only ever a few gridding questions on the SAT. The majority of the SAT is multiple choice. So give you all about 10 more seconds. And someone asks, would you grid in a decimal or a fraction? Either works. They accept both decimals and fractions. It's all about which form you feel more comfortable with. All right, I'm seeing a lot of variety in our answers, so we'll go over it now. Okay, so one of the key principles of this question, again, the SAT likes to draw on a bunch of key principles and apply them to the context of the questions that they write up. So this is a hypothetical. We don't see A and B in our actual question. So if A and B are real numbers and A squared equals B squared, then you either have A equals B or A equals negative B. So since we have 2x minus 1 squared equals x plus 2 squared, then we either have 2x minus 1 equals x plus 2. Again, this is just an extension of a equals b. Or we have 2x minus 1 equals negative parentheses x plus 2, which is our extension of a equals negative b. So if you want to take a second to kind of write that principle down, that would be great. But again, from here, it's a simple solve. So you have 2x minus 1 equals x plus 2, and you also have 2x minus 1 equals negative parentheses x plus 2. So if you solve for x by distributing and isolating for x on one side, isolating for your numbers on another side, you get that x equals 3 and x equals negative 1/3. So if you add up 3 and negative 1/3, because the question asked us what the sum of these solutions were, and we have two solutions here, you get that your answer is 8/3. This question was a little bit trickier because a lot of students tend to say 3 because they forget about the principle that if you have a squared equals b squared, then you also have a equals negative b. But again, this is just something that's important to know, and if you write it down and kind of practice with some problems on this, it'll be easier to remember. All right, so this is our third question. So this question here is a multiple choice, so you don't have to worry about gridding anything in, and it asks us if we have x squared plus bx minus 2 multiplied by x plus 3, and it equals x cubed plus 6x squared plus 7x minus 6, and in the equation above, b is a constant. So a constant means that it's a number 1, 2, 3, 4, 5 up to infinity. That's what the definition of a constant is. And if the equation is true for all values of x, well, what's the value for b? So again, we'll give you about 45 seconds. You can type your answers into the chat, and we'll go over some solutions and advice. Yeah, going back to that previous question, that was definitely one of the trickier non-calculator questions, just because A, it's a grid, and so there's a lot more variability in what your answers can be, and also because that's a principle that is less touched upon when you're going through your SAT math review. So if you want to check out the slides and kind of go through the explanation, let us know if you have any questions in the chat, or if you'd like us to explain it more, definitely feel free to go ahead. All right, so let's go over what the right answer is. So the correct answer for this question is coincidentally that B equals 3, and it's also option B that is the right answer. So good job to everyone who said B in the chat. All right, so some advice for this question. Again, this question tests your ability to utilize the distributive property. So you have to be able to expand the equation. Like we mentioned in our key concepts earlier, being able to manipulate polynomials, adding, dividing, subtracting, and in this case, multiplying will be very essential to your SAT. So again, the key to this question is to convert one side of the equation in order to match the other side, so that way you can compare the like terms and determine what the value of B is. So this is our worked solution. So if you have the left-hand side of the equation, which again for reference is x squared plus bx minus 2, which is multiplied by x plus 3, you can expand that. You can expand it in one of two ways. The way that I've done it here is I've taken x and I multiplied it by x squared plus bx minus 2, and then I took 3 and I multiplied it by x squared plus bx minus 2. But if you would prefer to take x squared plus bx minus 2, those three terms, and individually multiply them by x plus 3, you're more than welcome to do that. You'll get to the same answer anyways. So it depends on which method you're more comfortable with. For me, it was easier to multiply x plus 3 individually by the first polynomial that you see there. So once you multiply that up, you get x cubed plus bx squared minus 2x parentheses. So that was x getting multiplied by every term in the first polynomial. And then you have that added to 3x squared plus 3bx minus 6, which is 3, or the second value in the second polynomial, getting multiplied by the three terms in the first polynomial. So we can expand that out further because our main goal here is to distribute so that we can combine like terms. So then we get x cubed. There aren't any other terms here that have x cubed, so x cubed is by itself, plus bx squared plus 3x squared. So we're starting to combine and write down our terms that are similar, minus 2x plus 3bx minus 6. So again, we can still combine this further because we still have like terms that haven't been fully combined yet. They're just arranged nicely so that when we do need to combine them, we can. So now we have x cubed. Again, that doesn't change because there aren't any other terms that are getting multiplied by an x squared to become an x cubed. So that's our only cubed term here. And then because we have bx squared and 3x squared, we can combine that to get 3 plus b times x squared. And if you distribute that out, so if you multiply x squared by both 3 and b, you get what you had originally in the second step, which is bx squared and 3x squared. Again, a really great way to test and make sure that you're getting the same solution is to do what you're actually demonstrating in your steps. So if you wanted to go backwards from the third step into the second step and make sure that they're both equivalent, that would be great. It's another great way to catch any small mistakes like adding a plus sign in or forgetting a negative. So that's just another way to help you check. And then for our last part, since we have negative 2x and 3bx, we can combine the coefficients there like we did for the bx squared and the 3x squared. So we get 3b minus 2, and that all gets multiplied by x. Oh, there's a small error on the slide. It should just be multiplied by x, and then the negative 6 should be at the end. So the negative 6 should not be a part of the parentheses. That's an error that we'll fix, and then we'll put it up on the Bible website so that you have the correct slides when you're studying for your SAT. And so now that we've expanded the left-hand side, we've combined all of our like terms, we know exactly where everything is, and we've checked it over to make sure that once we've expanded it and distributed and we've checked it and everything makes sense, now we can compare it to the right-hand side of the equation, which is what we were given initially, which was that x cubed plus 6x squared plus 7x minus 6 is what we have for that right-hand side. So now that everything's been combined and expanded, we can compare everything from the left-hand side to the right-hand side. So there are two terms that have b on the left-hand side, 3 plus b times x squared, and also 3b minus 2 times x. Again, 3b minus 2 times x, not times x minus 6. So you can really pick whichever one you want. It doesn't make too much of a difference. But since it's visible that 3 plus b equals 6, we then get that b equals 3. So congratulations to everyone that said B in the chat. This is just a worked explanation of how we got there. And again, this question is testing your ability to rewrite expressions. Again, how we combined like terms distributed and then rewrote the expression to combine all of those terms and have everything in a neat form where we could compare things easily, and also manipulating polynomials. In this case, the manipulation was multiplication. All right, so moving on to our next sample question. Again, these are all non-calculator. We will be getting into the calculator allowed section soon, but for now, these questions are no calculator. So for this question, it asks, what are the solutions to the equation x squared minus 3 equals x? And there are bullet points here, but option 1 is A, option 2 is B, option 3 is C, and option 4 is D. So again, we'll give you about 45 seconds to break it down and work through it, and then we'll reconvene to talk about the solutions and advice. about 10 more seconds and then we'll go through this. All right, so the correct answer is D. So I saw a lot of D's in the chat, so good job everyone for getting the right answer, and no worries if you didn't. So one of the major key hints in this problem, and I'll go back to the question slide for a second, was that in the question itself, it asks for the solutions. And then if you do happen to look at your multiple choice options and you see that there are radicands and plus or minuses in each of the responses, it's a pretty key indicator that you're going to have to use the quadratic formula, because the quadratic formula is what directly gives you solutions. And more often than not, you'll get a solution in the form of something plus or minus the square root of something else. Is that the case for all quadratic formula solutions? No, but in this case, it does happen to be that way. So again, make sure you use the quadratic formula and complete the square. So first, you have to subtract x from each side so you can convert the equation into standard form. That's how the quadratic formula works. It only works if you have your equation in standard form. So if you're ever given an equation on the SAT where it's in vertex form or it's in another form that isn't standard, make sure you convert it into standard, because those are the terms that you're going to need in order to plug everything correctly into the quadratic formula. So once you subtract x from each side and you have your standard form, which again, a small reminder, is ax squared plus bx plus c, a and b are usually coefficients, then you have, and also there's a small error, it should be bx, not bc. So then once you've converted it, you get the equation x squared minus x minus 3 equals 0. Then you can note that a equals 1, b equals -1, and c equals -3. So now that you know these values, you can plug them into the quadratic formula and simplify to get choice D. So the quadratic formula, which again is not pictured here, but will be provided to you on your formula sheet most likely, which is -b plus or minus the square root of b squared minus 4ac over 2a, which again is a mouthful to memorize, which I believe is why they provide it to you. Once you have your a value, your b value, and your c value, you can just plug and chug and get your answer from there. So once you plug everything in, you square, you take the square root, and you divide, you'll get choice D. All right, so another sample question, again from our non-calculator section. This question asks that the function f at x equals x to the fourth power minus 2.4x squared. And this is graphed in the xy plane where y equals f at x as shown to the left. So if k is a constant such that f at x equals k, and it has 4 solutions, which of the following could be k? Again, we'll give you about 45 seconds, type your answers in the chat, and then we'll reconvene and go through the solutions and some advice. Yep, just taking a look at the chat. So if the quadratic formula is not given to you on your formula sheet for the SAT, again, some common formulas that they do include are volume area. They might include surface area for different shapes. If it isn't provided for you, then it would be a good idea to maybe just spend a couple minutes every day practicing it to make sure you remember it. Or if not, maybe just having it on a note card and memorizing it before your SAT, and then, of course, leaving your note card at home or taking a look at it right before you go into your testing center. Another more difficult way to get the quadratic formula, if you ever forget, oh, was it negative b, or was there a plus or minus here? Again, this is a more time-consuming way, is you could actually set 0 equal to ax squared plus bx plus c, and then solve for x that way by factoring, dividing, doing some more complicated steps. You would be able to derive the quadratic formula that way. Again, it's not an ideal way to get the formula, especially when you have limited time per question. So again, just memorizing it would be an easier way of remembering it for your test. All right, 10 more seconds and then we'll go through this. All right, so the correct answer is C, or that the value of k should be -1. All right, so some quick advice before we jump into the solution, or that this is a solution. So the question is asking for you to find a value of k where you have 4 solutions. So a solution means that the graph of the horizontal line of y, so horizontal again means like this, must intersect the graph of f at exactly 4 points. And this only works when f at x equals -1. So if we go back to this graph, if you can look at the value of f at x, or the y value, where x equals 0 and f at x equals -1, you'll see that there are 4 points of intersection here, or 4 solutions. So that's why the value of k, the solution line, or a horizontal line, that's why it has to be -1 and not 1, 0, or -2. Because if you look at 1, you only have 2 solutions here. Actually, no, you don't have any solutions. Actually, no, you do have 2 solutions. Apologies. For 0, you have a double rooted 0. Again, that's not 4 solutions. And then at -2, you don't have any solutions at all. So that's why C, or -1, is the correct response. All right, so I believe this is our last, or second to last question before we jump into the calculator aloud section. So for a certain reservoir, the function f gives the water level f at n to the nearest whole percent of capacity on the nth day of 2016. Which of the following is the best interpretation of f at 37 equals 70? Again, we'll give you 45 seconds. You can type your answers in the chat, and then we'll discuss what the advice is and what the solution is. About 10 or 15 more seconds. All right, so the correct answer is choice C. So I saw a lot of C's in the chat. Again, great job, everyone, and no worries if you didn't get it right. We'll go over it now. So since we're told that f at n is a function depicting the water level on the nth day of 2016, we're given that n equals 37 and f at n equals 70. So since, again, n is the nth day of 2016, if n equals 37, then our question directly relates to the 37th day of 2016. And since the function is equal to 70, then we know that the water level on that day was at 70% capacity because f at n is a function that's depicting the water level. Again, this is one of those critical skills that we talked about in the beginning, where you'll be given a function or you'll be given some information in a question about a function or what a function represents, and you'll have to analyze what it means and interpret and apply it to different scenarios. So applying the fact that n may equal 37 or it might equal something else, and also if f at 37 equals 70, what does the 37 mean and what does the 70 mean? All right, so now we're going to go into our calculator aloud section. Some of these questions are trickier. Again, this entire section, quadratics and advanced math, all of these questions are a bit trickier than normal. So I'll give everyone about 30 seconds maybe to go and grab your calculator so that you can use it for our section here. And if you have any questions before we go into our calculator section, you're more than welcome to ask it in our chat. All right, so let's jump into our first calculator aloud question. So if x minus 12 equals the square root of x plus 44, again, x plus 44, that entire quantity is under the radicand or under the square root, what are all possible solutions to the given equation? About 20 more seconds, and then we'll go through our advice and our solution. All right, so I'm seeing in the chat that we have some Bs. We also have some people saying D. I'm glad that there are a couple different options that people are seeing as the correct response, because that shows that there are definitely some things we can go over. So great job to everyone in the chat as well. So the correct response is B, but this is one of the trickier questions, and they intentionally word it as all possible solutions to try and trip kids up. So let's go through our advice and our solution. So again, this question is drawing on your ability to use radicals and use the quadratic equation. Not really the quadratic equation as much. It's more drawing on your principles of manipulating polynomials, factoring, and expanding and distributing. So we're given that x minus 12 is equal to the square root of the entire quantity x plus 44. So our first step is to square both sides of the equation. So we get x minus 12 squared, and since x plus 44 was under the radicand, once we square it, it's just x plus 44 afterwards. So we can expand the equation on the left, which is x minus 12 squared, to give us x squared minus 24x plus 144, and on the right-hand side, it's x plus 44. So once we subtract the 44 from the right-hand side, not the 144 on the right-hand side, it should just be a 44, you'll get x squared minus 25x plus 100 equals 0. You can factor this out to get x minus 5 times x minus 20. So your solutions should technically be 5 and 20. But our correct response, if you remember, was B, which was only 20. So why is it not both 20 and 5? Because that would make sense. So it does seem like 5 and 20 satisfy our requirements, but it's always good to plug back 5 and 20 into your original equation to make sure it works. So let's plug 5 back into the equation. So our original equation, again, was x minus 12 equals the square root of the entire quantity x plus 44. So let's plug in x equals 5 to that equation. And we'll get 5 minus 12, again, x is substituted in for 5 here, and 5 minus 12 equals the square root of 5 plus 44. So 5 minus 12 gives us negative 7, and the square root of 5 plus 44 gives us the square root of 49. So does negative 7 equal 7? It does not. So that solution, or 5, is categorized as extraneous, and if you plug 20 in, which you can do on your own, you'll understand that, or you'll get that that is the correct response and it's not extraneous. So again, this is just one of those trickier questions where they specifically say all possible solutions to try to get you to put 5 and 20 down, but it's always good to go back and check your solutions, plug everything back in, and make sure it works before you head on to your next question. All right, this next question is a lot to read. It's a bit of a mouthful, but again, this is just asking us for an equation at the end. So this question is telling us that there's a car that's traveling at x feet per second. The driver sees a red light ahead, and after 1.5 seconds of a reaction time, then they begin to apply the brake. After the brake is applied, the car takes x over 24 seconds to stop, during which time the average speed of the car is x over 2 feet per second. If the car travels 165 feet from the time the driver saw the red light to the time it comes to a complete stop, which of the following equations can be used to find the value of x? So again, take some time to break down this word problem, write some equations from it, get all the information you need. I'll give you a little bit extra time on this one so that you can break it down and get all the information you need, and then we'll come back and go through our solution and our advice. And if you have any questions, you can ask them in the chat, and also type in what you think the correct response is. All right, 30 more seconds and then we'll go through the solution. This is definitely one of the trickier questions that we've seen so far. Sure. So someone asked in the chat before we reveal the solution or advice, do we have any hints or tricks to solving it? Yeah. So there are a lot of words in this word problem. So the easiest thing to do would be to pull out the information that you need. So really the key information is that you know x is in feet per second, you know that there's a 1.5 second reaction time, you know that it takes x over 24 seconds to stop, and that the average speed is x over 2 feet per second, and that you have 165 feet from the red light to the complete stop. That's really the key information you need. And when you're trying to come up with your equation, another key thing is that you don't want to be adding quantities that are feet over seconds or feet per second and then add that to feet, or add that to seconds, or have a bunch of different units that you're adding up. When you are setting your equations equal to each other, you should have feet plus something else. So those should be your main units. You shouldn't be adding up any units that are different. So for example, you shouldn't be adding up 165 plus x over 24, because the 165 units would be feet and the x over 24 second units would be seconds. So different units, can't add them. My biggest hint for this would be to get everything into the same units, and then you'll be able to figure out an equation from there. So now we'll actually go through what the solution is. So the correct answer is D. Again, this is a trickier one. No worries if you didn't get it. We're going to go through our solution, and hopefully you feel more confident in your answer or what our answer is after we go through it. So again, we have a 1.5 second reaction time. We know that x is in feet per second. So the car travels a total of 1.5x feet. You multiply the 1.5 second reaction time times the x feet per second to get 1.5x. So that's the first bit of key information that we need to remember. So then we can move on to the second part of the question, which tells us that the average speed of the car during the x over 24 second braking interval is x over 2 feet per second. Again, you're given x over 24 seconds and x over 2 feet per second. If you multiply feet per second and seconds, you're going to get units of feet. And hint, those are the units that we're looking for. We're looking for units of feet. So again, the first part of the question, we have 1.5x feet. And now when we multiply x over 2 times x over 24, we get x squared over 48. And then those are the units that we have there are feet. So the last bit of information we're given in the actual question is that the total distance traveled from the red light to the complete stop is 165 feet. So your equation should be that 1.5x plus x squared over 48 equals 165. And a great way to check this would be to make sure that your units are all the same. 1.5x, those units are feet. X squared over 48, those units are also feet. And the 165, those units are also feet. So again, when we look back at the multiple choice options, we don't see anything that even looks remotely similar to 1.5x plus x squared over 48 equals 165. So we can rewrite the equation by putting our highest order x terms first. So we'll have x squared over 48 first, plus 1.5x minus 165 equals 0. You can multiply each side by 48, so that way you get a coefficient of x, which is 1, which is what our question actually asks for. So then you'll get x squared plus 72x minus 7,290. So again, this was probably one of the trickiest problems we've seen tonight. Again, always make sure and check that your equation has the correct units. Like we mentioned earlier, you shouldn't be adding feet per second and feet. If you can multiply those to get common units, that's what you should be doing. Someone else asks, how do you know if x should be in feet while checking your answer? Does it mention it in the problem? It does not explicitly mention that your answer should be in feet. It's just a good way to check, because if you go back to the question, we're given a bunch of different units: feet per second, seconds, feet. But we have to be able to combine everything. That's the key thing, right? Because when we come up with an equation, everything has to be in the same units. So when we look at the last bit of information we're given, which is that it takes it travels 165 feet from the time they saw the red light to when they came to a complete stop, we aren't given a time interval there. So those are the only units that we have in feet. So that limits us to what we can actually use in our equation. So since they only give us 165 feet and they don't say it took them 165 feet and they went for about 4 seconds, they only give us feet, that limits us and says, okay, I have 165 feet here. I need to get everything else into feet because this is limiting me. I don't know the seconds. I don't know the feet per second or anything else like that. I'm only given feet. That's limiting me. And now I have to convert everything else into feet so that way I can add them all together to give me my equation. Yeah, exactly. So since it says x over 2 feet per second, it would be like saying x feet for 2 seconds. And we can go over this one at the end too if you have more questions. All right, so another question. A store manager estimates that if a video game is sold at a price of P dollars, the store will have a weekly revenue in dollars if R at P equals negative 4P squared plus 200P. Which of the equivalent forms of R at P shows, as constants or coefficients, the maximum possible weekly revenue and the resulting price? I'll give you about 30 seconds to solve this one, and then we'll reconvene and talk about what our advice and our solution is. All right, so we'll go through this one just for the sake of time now. The correct response is D, and the key hint for this one is that you should notice that since the coefficient of p squared is negative, it's going to be a downward facing parabola. So the vertex is our maximum point. That's true of any downward facing parabola. And if you look to the right, that is the graph of negative 4p squared plus 200p. And because we want to find out what our maximum point is, we want to rewrite the equation in vertex form. So when we rewrite it in vertex form, we get r at p equals negative 4 parentheses p minus 25 squared plus 2500. And again, that means our vertex is 25 comma 2500. So that's the equation that we want to have written in. Another key tip is to use your graphing calculator to help you visualize this. You can type this into your calculator as negative 4x squared plus 200x. You can graph that, look at it, realize, oh, it is a downward facing parabola, so the vertex is my maximum point, and then you can use completing the square to help you write it in vertex form. So this is a great way to combine your calculator skills and your quadratic skills to help you find what the answer is. And I won't go through this fully, but these are our steps on completing the square in case you want to go through that and make sure that you have everything down for converting negative 4p squared plus 200p into negative 4 parentheses p squared minus 25 minus 2500. All right, so that concludes our math stream for today. Here are 2 memes to kind of send you off for the night and for the rest of your SAT practice. There are 2 here because I like them both and I couldn't pick which one was my favorite. So you can take a look at that if you would like to. And that is it from us. So if you have any questions, I will stick around and Jed will also be in the chat to help you answer any questions that you might have in terms of quadratics, advanced math, the SAT in general. But this does conclude our math-specific portion of the SAT. We hope you enjoyed it. And as always, if you have any questions, feel free to reach out to us, follow us on social media, and we hope that these sessions were helpful for you.